Dan Howe with LMI Technologies. I'm a regional development manager out of Detroit, Michigan, here in Chicago at the Automate 2017 show. This show is a fantastic show for users that want to do factory automation. There's a lot of robots here, a lot of technology, including our technology, which is 3D vision. And the show has been fantastic. We're on the third day now. There's been lots of traffic, lots of interesting questions from customers, and I think they're getting a lot of value. We certainly are, for sure. There are different types of applications in different industries, 3D scanning, and automation. It's a fantastic show. So this year we've launched a number of products that we didn't have at the last Automate. We use laser line scanning technology, including our 2400 series, which is higher speed, higher accuracy than our past products. We also have a much wider, advanced tool set. Lots of onboard tools to do measurements for various applications. We also have our snapshot technology, which we've at this show launched our 3210 and 3506 sensors. These are high precision, structured light scanning technology, all in a box where we've got our full tool set on the box.
I'm Paul Von Drack with LMI Technologies. I'm the Central Region Territory Manager for the U.S. And what we have here is basically a demonstration of 3D pick and place, multiple applications being displayed, linked with basically driven by a GoCater 2340 laser profile sensor mapped directly into a UR robot over Ethernet using standard communications ASCII protocol. So there's nothing more here than basically the GoCater, its standard tool set, and the UR robot. The examples that we're showing are pick and place to stack and unstack, similar to a palletizing or depalletizing application, random placement and picking off of a conveyor, and then finally we're doing structured bins by basically height of the parts. We have 1, 2, 3, and 4 stacks high, using the 3D information to basically put them in the appropriate bin and set them at the appropriate clock angle through the part matching algorithm inside the GoCater. So as far as tool-wise, we're using nothing more than 3 tools. So it's 2 bounding boxes and a height tool, and part matching enabled in the unit in order to perform all 3 functions.
My name is Tony Crocker. I work for the Brass Company, and I'm an applications engineer. Brass sells a wide variety of products along the automation lines, and some of those products are robots like the Universal and the LMI GoCater. And the GoCater is very easy to work with. One of the nice things is that it's pre-calibrated at the factory, so you don't have to convert from pixels to some measurement units. Those units are already there. So when integrating with the robot, you actually have less steps to integrate the GoCater than you would maybe a traditional camera. So that's very nice.
So I'm Paul Oberle. I'm the Director of Business Development for 3D Infotech. We've been a partner of LMI's for a good number of years, and what we're looking at today is universal metrology automation. And in this case, we're actually utilizing the brand new 3210 sensor from LMI. It's factory sealed, IP67 rated. Basically just happened is we just captured some data just a minute ago, and now we've aligned it to the CAD model. We've captured some discrete points along the surface of the part so we can analyze how repeatable the process is and how close we are to the nominal ideal. And then there are also some features that were measured in the background that have to do with the cylinder, some cylinders and the angle between those cylinders, as well as some flat plane, which is the mating surface along this area here for this throttle body. What's really incredible to us in the new generation GoCater 3210 is that it gives us a significant order of magnitude better result. Just instantaneously we're able to, in a second you'll see the alignment of the data, the the position of the scanner is recorded, so we have the inverse kinematic chain recorded at every point in time. But as you can see, in about 1 second, we've aligned and best fit the data together. And the only reason why that's possible, that it can be so quick, is the fact that the data that's captured from the 3210 is so much more refined and precise. So it's actually improved our cycle time by a significant margin.
My name's Ira Greenberg. I'm a business development manager with Bluerist Inc., and we work with channel partners for distribution and system integration throughout the United States. Bluerist and LMI have been working together over the last 10 years to deliver cutting-edge systems to the automotive industry. So using the GoCater allows us to basically run inline 100% inspection of manufactured parts. Our software comes complete with trending capabilities to monitor the process in line during production. So there's no need now for random sampling of CMM parts. We can move this system inline 100% part inspection using the wonderful technologies that the GoCater has to offer, paired with our Comic Stream software, allowing us to connect various devices together. So we have interfaces to various robots to allow them to read the data from the LMI sensor, transfer that through to our Scan Extreme software for analysis and processing. Yeah, so here we have the new Fanuc CR7 collaborative robot with an LMI GoCater 2340 laser profiler mounted to it. We're using the robot as motion to drive the sensor to acquire our point cloud. We're taking multiple passes, stitching them together to a single image, running comparison against the CAD model in our Scan Extreme software, allowing for feature measurement, feature extraction of various holes, slots, and trim edges. Furthermore, once that is complete, we are running a local surface comparison against the CAD model for any deviations in the production process. So this will show any dents, scratches, or pitting on the part.